Hi DSA Math 1 students. Welcome to our first day of virtual learning. I'm Miss Hamilton. Each day you'll have a short video tutorial to watch, some optional practice, and a progress check to make sure you understand that day's lesson. Let's get started. In this lesson, we're going to review the three main skills we worked on the last week we were together. Please pause the video and find some paper to take notes. Title your notes, Lesson 1, Multiplying and Factoring Quadratics. Alright, let's get started. So the first thing that we learned in this unit was how to multiply binomials together. And our answers were always going to give us a quadratic. So when we factored quadratics, this is how we could check to make sure that our answers were correct. What we're going to do right now is try this example together. So I have 3 times x minus 2 times 2x plus 3. When you have three factors that you're multiplying together, you always want to try to treat them as if they're in separate groups. I'm going to start by multiplying 3 times x minus 2. So I'm going to distribute the 3 to the x and the 3 to the negative 2, and we get 3x minus 6. Because all of that was together and it's all being multiplied by 2x plus 3, I want to keep it inside its own set of parentheses. And now it just becomes multiplying two binomials together. So you can either use the area model or you can distribute. I'm going to show you guys by distributing. So I need to multiply this 3x by everything inside the second set of parentheses. So we have 3x times 2x plus 3. And then I have to take this negative 6 and multiply it by everything inside that second set of parentheses. So 2x plus 3. Now we distribute again. So 3x times 2x gives me 6x squared. 3x times 3 gives me 9x. Negative 6 times 2x gives me negative 12x. Negative 6 times 3 gives me negative 18. So our last step, once we finish all our distributing, is making sure there's nothing that we can combine together. So in my classes, we did this little trick where we underlined based on the degree. So this one has a degree of 2, so we have 2 underlines, degree of 1, degree of 1, degree of 0. And then we see that the two things with the same degree, we can combine together because those are like terms. So my final answer is going to be 6x squared minus 3x minus 18. So if you have any questions about this section of the video, feel free to add those to our collaboration document, and then your classmates can help answer those questions. Let's move on to example 2. All right, so the second skill that we worked on was how to factor out a greatest common factor. We learned the strategy for finding the greatest common factor by using factor trees. So off to the side of my paper over here, I'm going to break apart each term into its prime factors. So I have 24x to the 4th. 24 I can break apart. You can do it in many ways. I'm just going to choose to do 6 and 4. And then we can do 3 and 2 and 2 and 2. So this is going to be equal to 2 times 2 times 2 times 3. 1, 2, 3, yep. And then there are 4 x's, so times x times x times x. All right, now I need to do the same thing for the next two terms. So 8x squared, that's 4 and 2 and 2 and 2. So we have 2 times 2 times 2 times x times x. And then finally we have 6x. I'm going to ignore the negative until the end of the problem. So we have 2 and 3, and that gets me 2 times 3 times x. So what I'm looking for in my factors are groups that show up in all three of my terms. So for example, 2 is in all three terms. There's another 2 here, but there's not another 2 in that third trinomial, so I can't circle that one. So the only other thing that all three have in common is an x, which tells me that my greatest common factor is 2x. Now this problem says that I need to factor out a GCF. So what that means is my final answer is going to have my GCF on the outside, a 2x, and then we're going to have whatever the result of dividing each term by the GCF inside the set of parentheses. So essentially we're rewriting the original problem as a multiplication problem where we multiply our greatest common factor by the result when we divide each term by the greatest common factor. All right, so 24x to the fourth divided by 2x is going to give me 12x to the third. 8x squared divided by 2x is going to give me 4x. And then be careful here, there's a negative sign, so negative 6x divided by 2x gives me negative 3. And this is my final answer. Once again, if you have any questions about example 2, please make sure you add those to our collaboration document. Me and your classmates will be able to answer those questions there. All right, let's move on to our last example together. Example 3, factoring a trinomial. So this is where we did the full shebang. We factored out a GCF, we used our diamond, and we ended up with a final answer that usually was like 2 binomials multiplied together with a GCF on the outside. So our first step when we factor a trinomial is we want to look for our greatest common factor. So you could do the side work just like I did back in example 2. So we could have all of this work shown. But for this one, I'm going to kind of skip over that because we talked about it last time and just tell you that the greatest common factor is 7, which makes sense because that's the biggest number that goes into 14, 35, and 21. So we need to factor that out. So I'm going to write a 7 on the outside, and then we need to divide each of our terms by 7. So 14x squared divided by 7 gives me 2x squared. 35x divided by 7 gives me 5x. And negative 21 divided by 7 gives me negative 3. So here's where I want to identify my A, B, and C terms. And remember, we're using the terms inside the parentheses, not the original problem. We want that factoring out the GCF is supposed to make our numbers smaller when we set up our diamond. So A in this problem is the coefficient of the quadratic term, or 2. B is the coefficient of the linear term, so 5. And then C is our constant. And don't forget that negative sign, it's really important. So when we set up our diamond, in the top of our diamond is always A times C. So in this problem, that would be negative 6. And then in the bottom is B, so 5. So what we're looking for are 2 numbers that multiply together to give us negative 6 and add together to give us 5. So we know because this top number is negative, we're going to have one negative answer and one positive answer. And then because this bottom number is positive, we know that that positive number is going to be the larger one. So in this case, it's going to be positive 6 and negative 1. All right, so then we're going to use those 2 terms in the diamond to split apart our linear term. So 5x, I'm going to rewrite as negative 1x plus 6x. And then we just carry down the rest of the problem. So I'm going to bring down that negative 3, bring down that 2x squared, keep my parentheses, and then put the GCF on the outside. Now we come to the part where we factor by grouping. So I'm going to group my first 2 terms together and my last 2 terms together. My greatest common factor of this first group is just x. So when I divide each term by x, I'm left with 2x minus 1. And then here, my greatest common factor is 3. So I'm going to put a 3 on the outside, divide each term by 3, and we get 2x minus 1. Right, and then just so that I don't forget it, I'm going to keep the GCF on the outside. So we've done everything correctly. These binomials should match, and they do. So I'm going to bring that down, 2x minus 1. That's my common binomial factor. And then if I divide each term by 2x minus 1, so if I divide this piece by 2x minus 1, x is what we have remaining. And if I divide the second group by 2x minus 1, the 3 is remaining. All right, and then we can never forget that we always have to have that GCF in the front, because when I multiply these 3 factors together, I should end up with my original product. Once again, if you guys have any questions about example 3, please add it to our collaboration document. Hope everybody's staying healthy and safe, and we'll see you guys tomorrow.